Hey folks, so today we're going to talk a bit about AI software engineering agents and how to use them effectively. A bit about myself, I'm the CEO at OpenHands AI and we're the makers of OpenHands. OpenHands is an MIT licensed software development agent, currently the top performer on Sweetbench Verified. You're welcome to check it out on GitHub at allhandsai/OpenHands. So just to start by stating the obvious, software development is changing. I think we've all seen our jobs change very significantly over the last year or two, and it's very clear that that trajectory is just going to keep continuing through 2025 and 2026. In particular, I think writing code is going away. I spend a lot less time in my IDE these days, and it's less and less as time goes on. I think writing code is becoming a very small part of the software engineering job. But engineering itself is not going away. I like to think of AI-driven development as a way of replacing the rote mechanical aspects of our jobs, the things we don't like to do, and making more room for creativity, imagination, critical thinking, the parts of our jobs that are actually hard and fun. So what is a software development agent? What is it that's actually catalyzing this transition? So at the heart of the word, I think that word agent tends to, it gets thrown around a lot. I think the definition is getting kind of wobbly, but at the heart of it is this word agent, or agency, right? It's all about being able to take action in the real world and actually have an effect on the world. So if I were to give you a few tools here, like a code editor, a terminal, and a web browser, you can do quite a bit with these tools. You can basically do the entire inner loop of software engineering. Within the code gen landscape, I think there are a few different tools that are available, and agents are kind of one part of the picture here. So I like to kind of lay out the landscape here. And in particular, if you look along the x-axis, you'll see kind of at one end of the spectrum, you have these very, very tactical tools that live inside of your IDE. So GitHub Copilot is a very extreme example here, where it's really, it's inside your IDE, it's editing the code wherever your cursor is pointed inside of the code base right now. It's really like if you're deeply engrossed in a problem, you're actively working on it, the AI is helping you go faster. But then at the other end of the spectrum, on the more agentic side of things, you have these tools where you really just have to give a high-level instruction to the agent, maybe 1 or 2 sentences of English, and it goes off and works for 5, 10, 15 minutes, and then comes back to you with a solution. This is a much more powerful workflow. You can do multiple things at once. You can have many of these agents going. You can stay focused on a coding task or stay focused on communicating with your coworkers while these agents kind of go off and do small tasks for you off on the side. It's a very, very powerful way of working, but it's also a very different way of working, right? You're not inside of an IDE. You're not actively hitting keys on your keyboard. You're more, it feels more like managing than it does actually writing code. So I think if we want to learn how to use software agents effectively, it makes sense to talk about how they work under the hood. At its core, the agent is this loop between an LLM and the external world. Basically, what we do is we start with some kind of prompt, like making a hello world script. We send that up to the LLM. We get some kind of action back from the LLM that's like, I want to read this file, I want to run this command, I want to browse this web page. We get some output from the real world, the contents of that file, contents of the web page, the output of the command, and then we stick that back into the LLM for another turn of the loop. And we basically keep iterating here until we reach some kind of finished signal. Maybe the LLM has signaled, OK, I think I'm done, or the tests are now passing, whatever else. But it's this loop between the LLM and the real world. We talked a little bit about the actions that are available to the agent. I think one of the most important one, if you're going to be writing code, is this code editor. This is a surprisingly tricky thing to get right. The naive implementation of a code editor for an LLM would be, you give it the old contents of the file, and it spits out the entire new file. That's not a very efficient way to work, though. You can imagine if you're just changing one line in a file that's thousands of lines of code, you don't want the LLM to have to output that entire file. It gets very expensive, it gets very slow, and it's also not super accurate. The LLM might make a mistake, on line 502. It might change your tabs to spaces or something like that. And so there are much more sophisticated strategies for code editing these days, using like a diff-based editor, just doing like string replacement, things like that. And most modern agentic frameworks do have some kind of more sophisticated way of editing files these days. There's also lots of cool stuff you can do with like abstract syntax trees and things like that to help the LLM kind of navigate the code base. Next big thing is the terminal, right? The LLM has to not only be able to write code, but it has to be able to run the code that it writes. It has to be able to run unit tests, see if they're passing. And this, again, is deceptively tricky. There are problems like commands that take a long time to run, or maybe run a long time without any standard out. How do you allow the LLM to maybe interrupt that command? Do you have some kind of timeout set up? How do you run multiple commands at once? Can the agent deal with like standard in? So like if it tries to apt-get install something, it needs to like hit the Y key to keep going. Making sure that the agent has a real kind of like live interaction with the terminal the way a developer would is tricky, and it creates some really interesting problems. And then finally, probably the trickiest piece of the puzzle is the web environment. This is a crucial part of a developer's toolkit, right? We need to be able to look up documentation. We need to be able to go to Stack Overflow and like see what other people have done when presented with a similar problem to what we're facing. And again, this is really tricky. The naive solution might be to let the agent specify a URL and spit back a bunch of HTML, but that's again very expensive. There's a lot of stuff in the HTML we don't necessarily need. We have strategies like converting that to Markdown or converting that to an accessibility tree. Really interesting things come up when you want to do interactivity, right? You might let the LLM just like write JavaScript against the web page that came out. You might give it a screenshot with like labeled buttons and things like that and tell it where to click. You might let it click any particular coordinate on the page. There's a lot of different ways to do this. It's something we're actively experimenting with. We actually have one of the most accurate web browsing agents available today. A really important part of this puzzle is sandboxing. So you might be tempted to just like give the agent access to your computer, your web browser, et cetera. That's a really scary thing to do. There's nothing necessarily stopping the agent from just saying rmrf/ and obliterating your machine. Or if you give it access to your browser, like there's nothing stopping it from like going into your Gmail and sending a bunch of random emails. So having some kind of sandbox environment for these agents to operate in is a much safer way to work. And it allows you to run them in a way that you can just kind of like let them go. You don't have to watch over their shoulder. You don't have to hit the Y key every time it wants to run a command. It can just kind of do its thing while you focus on other things. So this is a really, really important part of the puzzle, A, for safety, and B, for your own peace of mind, for your own ability to work with these agents without being paranoid and trying to babysit them as they do their work. I think the way we start to bridge those two worlds between the sandbox and the real world, though, is by giving credentials to the agent. And so increasingly, we are providing users with ways to, say, plumb in API keys. The agent, for instance, has access to a GitHub key that allows it to push and pull from GitHub, and making sure those keys are as tightly scoped as possible so the agent can't do anything that it shouldn't. And maybe ask permissions if you are going to give it access to AWS and let it deploy things. Maybe it has to ask for permission first. So this kind of like sandboxing and security aspect is a big part of the puzzle. The more and more we give these agents autonomy. So I just want to talk a little bit about best practices for actually using software agents now that we've kind of talked about what's going on under the hood. My biggest advice is to start small. I think a lot of people will show up to a coding agent with very high expectations. They'll be like, okay, go make a clone of Facebook, and then they'll be disappointed when the agent just falls over in the middle of that task or doesn't quite get there. I think starting small with little tasks like my favorite is fixing merge conflicts. If I've got a PR up that hypothetically it's been approved, but somebody else has edited the same file, I can just say at OpenHands, fix the merge conflicts. It'll kick into gear. It's a very rote task. It's very easy for me to verify that it's done correctly. So just starting with small tasks and starting to build that intuition, and then you can kind of grow over time with the level of things that you're willing to throw at the agent and have a high degree of confidence that it's actually going to be able to achieve it. Number two is to just always give clear instructions. The more you can elaborate on what exactly you want done, the better. I think this is a lesson that I had to learn when I switched from writing software to managing software engineers, is that if you give somebody ambiguous instructions, they'll often come back to you with a solution that wasn't at all what you wanted. So being very clear about not only what you want, but how you want it done is super important. The more you can give the agent a clear tech stack to work with, or tell it which particular files you would like to see edited, names of particular functions, the more precise you can be here, the better the agent will do. And then I think most importantly here, always review the code that the agent writes. I've seen several cases where things go wrong, where somebody decides, oh, I'm just going to vibe code my way to a solution here. They'll keep prompting the agent and asking it to do more and more, keep adding features with new prompts to the agent, and they'll maybe click around the UI and make sure that the behavior was correct. And it works for a little while. It works for maybe several days. I've even seen it work for weeks as you build and build and build this application. It gets more and more complex. And then you finally peek under the hood, and it's a total mess. There's duplicated code everywhere. Things haven't been architected properly. And all of a sudden you get to a point where even the agent, you throw a prompt at it and it can't figure out what file it should be editing, and can't figure out where this bug is coming from. And so really at every step in the process, you need to be reviewing the code the same way you would another engineer's code. You can't just assume that the AI knows everything it's doing. It does stupid things sometimes. It hallucinates sometimes. So making sure that you're going through your normal code review process and have the same guardrails in place for an AI engineer that you would for a human engineer is super, super important. Digging into that a little bit further, I think it's really important to talk about trust and ownership in the world of AI-driven development. And in particular, I think it's really important to understand that you do need a human in the loop. These agents they make mistakes in ways that aren't always intuitive. They make mistakes that would be silly to your average human being, even though they're also intelligent in ways that are just totally inscrutable to us. So it's really important that we have a human being kind of guiding these agents and prompting them to do the right thing. And then in particular, it's really important that you have a human being who can be basically held accountable for the changes that the agent is making. So in the early days of OpenHands, we actually had it set up so that when somebody wanted to make a pull request with OpenHands, the pull request would get open as OpenHands, and OpenHands would show up as the author of that pull request, and the little logo with the hands would show up as the picture. And that failed miserably for two reasons. One, it allowed the person who triggered that pull request to then approve it, basically just bypassing our whole code review process. There was no need for a second human to verify this was a change we wanted to make. And number two, a lot of times those pull requests would just sit there and languish because there was no clear owner of that pull request. If the tests were failing or somebody had asked for a change, there was no clear person to say, okay, this is my change. I'm gonna help get it over the line. And then if it did get merged and something went wrong, something was broken, it wasn't working right, there was nobody to hold accountable. So that caused a lot of serious social problems. And so now we have it set up so that if you open a request with OpenHands, that your face goes on that pull request. You're responsible for it. You're the one who has to help get it over the line. And if that code gets merged and causes problems, you're the one who's going to have to go through the revert process. You're the one that's going to be held accountable. That's just super important for the kind of social aspects of coding together. And a human being needs to own every change. And I really like this line, trust but verify. I think you can be much more productive with the agent once you trust it to do what it does well. It can write a lot of code. It knows basically every major API out there. It knows all the major libraries out there. I love it for writing Helm and Terraform, which I'm not an expert at. I don't want to just munge through documentation and the AI crushes it. But I always read the code. I always make sure the output looks reasonable. Making sure that you're watching the AI and making sure that the code that it writes makes sense. Super, super important. I want to talk about a few different kind of workflows that are available to us in an AI-driven development world. Kind of on that far tactical side, you have these local workflows like working inside of your IDE or working through a CLI like Claude Code. That can be a really powerful way when you are zoomed in on a task to move faster. But then you can kind of move down the spectrum towards the development outer loop and let the agent take on that whole inner loop. So there are web-based workflows where you could just fire up a site and like type in a prompt, maybe connect your GitHub repo, and the agent will just start working and push its code to GitHub and create a PR. Increasingly, we're seeing integrations with the Git providers themselves, so GitHub and GitLab or Bitbucket. One of my favorite workflows today is if I've got a PR that can't be merged for whatever reason, maybe I have approval, but there's merge conflicts or there's a test failing or something like that, let's just say, at OpenHands, fix it. I don't have to context switch back to that thing. It just kind of works. So these integrations into the Git providers is super nice, or just being able to like tag an issue with OpenHands fix this, and it just starts working. Super fun. And then we're starting to see integrations with all these other places where developers live and congregate. Basically anywhere at the collaboration layer between developers, these agents plug in really, really nicely. So a Slack bot, really fun. If you've got like a thread going about some bug that you've uncovered, you can just say, at OpenHands, please take care of this bug. It'll pull in all that context. It'll find the right context in your code base and just start working. Being able to pull into like Jira or Linear, wherever you're issue tracking. Really cool things you can do there to like break down tickets and just kind of automatically start working on things, just pull down your backlog. It's really fun when you can actually see, identify issues that are easily solvable by an agent. You can just take down a certain percentage of your backlog with one click. Really fun to see these agents starting to plug into basically everywhere developers would plug into. And then I think a really important part of the process too is customization. You all might be familiar with like cursor rules or Claude.md. We call these micro agents, but basically being able to take a generalist agent and specialize its behavior either to your particular needs as an individual user. Maybe you prefer tabs to spaces. Maybe you don't like all the little inline comments that AI likes to make. You can give it some extra instructions about how you personally like to work. You can also give it org level instructions. So like if there's a particular tech stack that your organization likes to work with, you can just kind of like put that in one place, and the agent can always just pull that in and have that context to work with. And then at the repository level, kind of in between those two, it makes things a lot better if the agent just knows up front, here's how you run the tests, here's the general like file structure of this repository. We've had a lot of luck with checking in like a glossary into each of our repositories. It talks about all the little terms of art that are specific to that repository. So if somebody says, fix the widget, the agent immediately knows what a widget is and like where that is in the code base. Super helpful. I think this is something that's very much worth investing in up front because it just makes agentic workflows so much more valuable and powerful the more you kind of invest in this sort of customization. And it's really easy too. It's just Markdown, right? And the more you can put in here for the agent to have that context, the better. And what's really fun too is you can ask the agent to build this context for you, especially with like micro agents. We do this all as code. All these files get checked into a Git repository, so it can be tracked over time, and you can like verify with your teammates that we're saying the right things. And you can just say to the agent, hey, like please explore my repository and create a micro agent for this repository. I do want to talk through a handful of use cases where software development agents are good. This is a tricky subject because they are generalists. I would say about 80 to 90% of the code that I write these days goes through an agent. But like I said before, it's best to start small, and I think highlighting a handful of use cases where agents work 90% of the time, very repeatable use cases that kind of come to us as developers on a day-to-day basis. One that I've already spoken to before, because it's literally my favorite use case, is resolving merge conflicts. This is my least favorite part of being a software engineer, is when like my PR was ready to merge, somebody else had touched the same file, and usually it's a very rote task. It's very clear that like all I need to do is move this line here, move this line here, and I love being able to just like shovel this off to an AI, let it do it for me. I don't have to like context switch back to that work or like look up what my coworker was doing and why there's a merge conflict. This is a really fun use case. Addressing feedback on a PR is another favorite of mine because somebody else has already clearly articulated what they want done. So somebody else has done the work of like prompting the agent for me, and all I have to do is just say, hey, OpenHands, just address the feedback. And it just works very nicely, especially if you have a good reviewer who's been very clear in what they want changed. Fixing bugs, especially like small obvious bugs where you already know kind of the solution. Like in this particular case, we had an input that was a text input. It was supposed to be a number input. I could have like found the right file within the code base to do this myself. Probably would have taken me like 10 minutes. Instead, I just fired off a prompt. I stayed in Slack and kept communicating with my coworkers. And then 5 minutes later, it came back and this was just done. This is a really nice, just anytime we have like a tiny little bug inside the app where it's very clear definition of done when this thing's fixed, very clear how to fix it, really easy to just shovel off to an agent. I really like it for infrastructure changes. I mentioned earlier I don't like writing Helm and Terraform. Often it involves like looking up some esoteric documentation to figure out what tiny variable name you need to change. And so being able to just like tell the agent, increase the memory in Redis, and it goes off and hunts around our infrastructure repo for the right place to set Redis memory. Really nice. It allows me to just kind of like relax a little bit more and not have to like squint at my computer screen and dig through documentation. Database migrations are one I really, really enjoy. I think because database migrations are generally kind of rote once you kind of know what you want. And also because I tend to get lazy with database migrations and I don't always have all the right foreign keys and all the right indexes set up. The AI actually has a really good set of instincts for how to set up database tables using best practices. And so I've really enjoyed it for database migrations. Fixing failing tests. If CI/CD is not passing, again, this is one of those like paper cuts that prevents you from merging a PR. You just got like one broken unit test because you changed an API. Just being able to call in the agent and say like, you can see what I did here. You can see what the intent of this PR is. Just get the test to pass. And there's a really clear definition of done again. You'll see that theme kind of come up over and over. The agents work best when there's a clear definition of done, when it knows, okay, the tests are passing, I'm finished, or the merge conflicts are done, and the linter's passing. That's a really, really good use case for the agent. One of my favorites is also expanding test coverage. I like this one because it's very safe. Checking in new tests is probably not going to break anything in production. And so if we identify a part of the code base that is really poorly covered, it's really easy to just say, okay, just go explore that part of the code base, figure out the best way to test it, add more unit tests. You can get some quick wins this way. And then everybody's favorite, building apps from scratch. I think this is really fun, especially if you've got like an internal application that you want to build or something that kind of like sits aside from your production application. We've done this for some like analytics. We wanted to like analyze our GitHub community traffic and stuff like that. Really easy to just kind of like vibe code a thing that's just going to sit on the side. It's not facing end users. It can be super powerful. We've built whole like internal tools that we just like wouldn't have done before because it would have taken too long. We can just kind of like iterate with an agent, and since it doesn't need to be perfect, in this particular case, you don't necessarily need to review every line of code as long as it's not getting shipped to users. So it is really fun to vibe code these like internal applications to get really fun things done on the side. I do want to just highlight OpenHands as an example, given that we're at the Open Data Science Conference. We've got an MIT licensed software development agent. We've got some really goals that mean a lot to me. I think getting these agents into the hands of every software engineer is going to be really important. Making sure that they have the tools to run those agents safely and effectively. Having that sandbox set up so that the agent's not just running loose on your computer and deleting files and whatnot. And then most importantly is doing this all in the open. It's very clear that our jobs are changing, and I think it's really important that software developers have a say in how that change happens. And so we really want to build a community of software developers to kind of like help define what the future of our job looks like. It's going to be changing, and like we need to make sure it changes for the better. We've seen a lot of great feedback from the community. I think the thing that makes me most excited is that we are drawing in folks from many different research institutions, which has helped our agent kind of stay at the top of the leaderboards for what the most accurate agents are out there. And I'm really excited about just the level of involvement we've gotten from the software engineering community so far. That's all I've got. I would love to see you all join us in the OpenHands community. We're on GitHub, allhandsai/OpenHands. I think we have a few minutes left if anybody has any questions.
Hey, thank you for the talk. How are you thinking about like testing and manual testing after you've seen the agent give you a PR to review?
Yeah, I think this is actually like a really, really important part of the process. So, I really like a test-driven development workflow where you set up tests ahead of time and making sure that the agent's going through the same like CI/CD process that your normal engineers would. Um, and I think manual testing is also a huge part of the process. Again, like in those early days when OpenHands was opening the PRs and its face was on each PR, a lot of times people wouldn't like pull down the code base and actually test it to make sure it worked. Now that their face is on the PR, I think they have a little bit more sense of ownership, and I think it's very important to pull down the code, make sure it's working. One workflow that we are starting to center on a lot more is having OpenHands set up an ephemeral environment for every change that it makes, so that you just have a link you can click on as long as it's a web app, and you can immediately just like see the code, verify that it did the right thing, verify that the bug was fixed, and keep going. But yeah, I think more and more of the job is shifting towards QA and towards code review.
Hi, thank you for the talk. We've used OpenHands before in our company, and we love it. Question for you, how are you guys solving the long context problem? We've noticed that using any of these code generation tools, at some point they break once we reach like hundreds of thousands of lines, and they are useless when it's millions of lines of code.
Yeah, it's probably the trickiest part of the problem is managing what goes into that context window. There's some low-hanging fruit that we've picked, like having better file editing so that you don't have to like drop the entire contents of a file in and then get out the entire contents of the file. We actually just shipped maybe a few weeks ago what we call our condenser, which basically at routine points in the, so as you go through a conversation with the agent, you're basically building and building and building context. Maybe it runs npm install and you get all this standard out that's now in the context window for every subsequent prompt to the LLM. And what the condenser does is it progressively summarizes older parts of the conversation so that you don't need the whole standard out of that npm install. You can just say npm install succeeded, right? So you can basically pull out context as time goes on so that that context window stays short and you stay within the limits every single time. But yeah, it's a very tricky part of the flow.
Thank you for a very inspiring talk. I wonder if you can give us some insights onto what other tools you're using to create specs and roadmaps. Are you just pasting into ChatGPT or?
Yeah, it's. I think this is something we're working on more and more. So we use Linear. I think it's really fun when we identify an issue inside of Linear that can just be taken down by an agent end to end. And increasingly, we are trying to like manually break those things down. We are working with some like automated workflows to like have an LLM break those tasks down, and B, have an AI look at a particular task and decide what are the odds I could solve this. Is this an achievable task for an agent or is it not? Is there a clear definition of done, et cetera? I think that's all still kind of like on the edge of reality today, but I would guess this year you'll see some really cool stuff to kind of bridge that gap between product management and AI engineering.
Have you had to overcome a lot of resistance from the team?
Resistance from software engineers on adopting these tools?
Yeah.
Yeah, it's a really good question. I think a year ago, there was some fear that AI agents were going to replace software engineers. I think it's become very clear to most of us that that's not going to happen anytime soon, that they're really a tool for making engineers more productive and reducing the amount of toil in our job. So that resistance I've seen fall away quite a bit. I think the trickier thing for the agents in particular is that it's a very different way of working, right? Copilot was really easy for everybody to adopt. We've been using autocomplete for years. That just kind of like plugged into the existing workflow. Agents are a very different way of working. I think it's very natural for a software engineering manager to adopt agents, but for individual software engineers, there's a little bit more, it's a shift in muscle memory that I think is difficult for many people to make that transition.
Thank you.
Yeah. Maybe one more?
Yeah, last one. I was going to ask if you're integrating with Purple Llama or any secure code frameworks to generate secure code. And just with the evolution, there's, I guess, a lot of defaults in coding, like like for example, hashing algorithm you're using for passwords, you might want to default to Argon 2 or something like that. So I'm just curious if you're looking at security or secure projects like Purple Llama as integration.
Yeah, so in terms of the underlying language model, we're totally language model agnostic, so you can plug in any language model you want. We do have we worked with Invariant Labs to basically add this security layer on top of the agent, especially if you're running in like a sensitive environment or with sensitive environment variables, where basically every action the agent wants to take, you send that to a separate LLM and say, is this a safe action to take? Or is this potentially deleterious? Should we ask the user for permission first? I would say that we're still kind of working through that, but there's a lot of really cool stuff happening there.
Cool, thank you.
Cool. So I think we have 30 seconds.
With the rise of software agents, what skills do you think are going to become more valuable in order to take advantage of the technology effectively?
Yeah, I think it's very similar to the skill set you would expect from a software engineering manager. So being able to like clearly articulate what you want, being able to break a big problem down into smaller problems, and then being able to basically do that like QA review and like making sure that people are doing the right things is really, really important. So less keystrokes and typing and more of that like high level architectural and communication skill set. Thank you all.